Hello everyone and thank you for watching. I'm going to explain this problem similar to what you have for homework. And our objective here is to fill in the input and output values to the function g using the input and output values of f, where g is defined as negative 1 over 9 times f of 1/5 of x plus 9 and then plus 7. Now, because we have information, we have a horizontal and vertical transformations. I suggest that we start with the inside transformation first, inside the parentheses of f of x. Now, because these are on the inside, they are affecting the input values, which are the x values here. So we want to start by seeing how are these input values going to change when we perform these two operations. Now, because we're affecting the input values, we're going to do the opposite of whatever these operations indicate. So instead of multiplying the x by 1 over 5, okay, and adding 9, we're going to do these things in the opposite. Now, normally we'll work on the inside and then work out or distribute right here, but because we have this notation, we start with dilations first. Also, always dilations first. So here, we're not going to multiply our x with this 1 over 5. What we're going to do is that we're going to divide this input value of x by this fraction of 1 over 5. And because we're adding 9 to the x, as you recall again in our examples in our notes, by looking at the transformation, that's going to shift everything in a negative direction. So we're actually going to subtract 9 to those values. So this is going to stretch the graph horizontally and shift everything in a negative direction. So let's see what the what the input values are going to change to. Starting off with negative 9. So our negative 9 is divided by 1 over 5, which ends up becoming negative 45. And we're going to subtract 9 to that. And that's going to be a total of negative 54. Now we do the same thing with negative 8. So negative 8 divided by a positive number, that's negative. And then we'll negative 8 divided by 1 over 5, that's negative 40. And then minus 9, negative 49. Negative 6 divided by 1 over 5, that's negative 30. Minus 9, that's negative 39. Negative 5 divided by 1 over 5, that's negative 25. Minus 9, that's negative 34. And then finally, the last one that we have for the inputs is 7. So positive 7 divided by 1 over 5, that's positive 35. And then minus 9, that will be a positive 26. So there we have the input values. Now, let's talk about the numbers on the outside. Well, the numbers on the outside are going to affect the output values. See how beautiful that is? Input, in, input, out, output. So now those numbers affect these output values. And the beautiful thing about this is that if we ignore what's inside here and ignore this and pretend that that's only an x, okay, f of x, you'll see that it matches to that symbol right there. Well, those are going to be those numbers there. And notice the notation that we have here. We have negative 1 over 9 times f of x and then plus 7. So we're literally doing exactly that to those numbers. We're going to multiply all of these output values with a negative 1 over 9 and then add 7. And if we think about this in terms of x and y, this right here are the y values. So I can write that my y values are multiplied by negative 1 over 9 and plus 7. So let's do that with these values. So negative 63 times negative 1 over 9, that's equal to positive 7. And positive 7 plus 7, that's equal to 14. So now 9 times negative 1 over 9, that's equal to negative 1, plus 7, that's 6. 27 times negative 1 over 9 is negative 3, plus 7, that's 4. And then negative 9 times negative 1, that's positive 1, plus 7, that's 8. And then negative 63 times, that'll be positive, negative times negative is positive, and 63 times 1/9, that's a positive 7. Oh, the same as before. And then plus another 7, that's 14. So there you have your table for the graph of G, which then you can plot or do whatever it is that you need to do, evaluate maybe G of something and get the value of those things. So there you have it. I hope this video was helpful and I appreciate you watching.